Good morning. Thank you very much for coming to this session. Um, Thank you very much for coming to a session about monolith, right? Because it seems that it's not so hype nowadays, monolith. So thank you. And what I'm going to explain you is how I would develop a monolith application nowadays with all the knowledge that I have about microservices. I know that most of the things that I'm going to say, you will say, it's common sense, I already know this. Sure that you already know, but the what I wanted you get it from this session is that there is more people that thinks that you can or you can still enjoy developing monolith applications. So I know that it's common sense, but it's worth to remind every time. I'm Alex Soto. I'm a Red Hat engineer. I'm the creator of lordofthejars.com, and you can follow me on Twitter. If you have any question, just feel free to ping me there and I will try to answer. And also, this is the irony, right, that I'm the co-author of Testing Java Microservices. Yeah, I know that it's an irony, but if you, I think that it's today and tomorrow, you can use this discount code. So you get like 40% of discount of the price of the book. So if you are also into microservices, then you can just buy it and see how to test microservices. Then I will share the slides, so if you check my Twitter, you will see the links. Finally, if you have any question, please raise your hand and I will try to answer, because it's a long journey today. I'm going to talk about several parts. So if you do the question just at time, then we have all the context. And the reason of this talk is about this discussion between Kaylee and my mate Burr, which basically they start discussing, and they maybe said that maybe we are currently into the through of disillusionment phase. That basically it's the phase that happens after everyone is adopting microservices, and basically this phase is where you are implementing microservice architecture, you get it to production, and then you see that there are some problems and you start failing and you are not really happy with the result, right? And this is normal. It's defined in the hype cycle graph. But even if you have failed, I think that it's important to learn things. And this is the reason of this talk. It's learning what offers microservices that can be also adapted to monolith. And this is basically, let's say, a really simplified microservice architecture where we have a front end. Usually you can even split the front end between services, but yeah, for simplification, I put it just one layer of front end. Then you have the security context, you have an API gateway, and then you have several services, all of them interconnected by network. Each of the service, usually it's a map to a bounded context in the DDD methodology. And usually there is different technologies in all the services and different teams developing it, right? This is, in summary, a microservice architecture. But what I'm saying here is that maybe instead of this, we can have this other thing where you have a front end and then we have all the services inside the JVM, so there is no more network connection, but just local calls. Of course, all the languages are JVM languages, and there are several teams, and maybe the front end, you connect with the front end even by using an HTTP connection, or maybe you just use some kind of these template languages like Themeleaf or FreeMarker or Velocity, so you get it on your server side, you render the HTML, and you send it back to the client. So let's see how we can apply some of the advantages of microservices inside this way of this architecture. One of the best things of microservices is the isolation between services, right? It gives you a common API to communicate between them. And the good things about microservices is that there is a physical layer, which is the network. So it's like, you have several services. Inside they have some code, but any service needs to use this common API. There is no way that one service uses an internal class of the other services. This is something that usually happens with monolith, right? That you have several modules, and then one module uses one internal class from another module because we are in a hurry, and then what we are end up is by having some kind of a spaghetti code right across all the monolith. So the thing is that, can we isolate our code in the monolith as it happens with microservices? And the answer is yes, and there are several ways of doing it. But in my experience, the best way is just using the modules that offers you the build tool, right? I mean that with Maven you can define modules with Gradle as well. So one way of splitting the code is using modules. And basically what I like is this kind of a structure where you have the root folder, and then you have, when you will have one microservices called game, then I have a module called game. And this game, it has two more modules. One would just called API, another EMPL. The same for review and the same for detail, and so on and so far. So you've got this layered structure where you have all the services, let's call it, although they are not services in the sense that they communicate by network, and the API and NPL. So what's happened with the API? The API is the public interface, right? It exposes in a small, well-defined, stable API. So it's just an Java interface, and it exposes only what is required, and it favors load coupling, because as I said, if everyone uses this API interfaces, then we'll never use the internal classes, so you get it out of having a spaghetti code. And then there is this MPL folder, which is like all the classes are private or packaged, or I mean that it doesn't matter the scope, but they are not public. It's highly cohesive in the sense that all the classes just communicate inside this module. There is no outbound communications. And finally, and this is really important, is that reduces our memory footprint, right? Because now, if you have not implemented this module, but you want to know what this module is doing, you just need to go to the API layer, check the Java doc and the interface, and say, okay, this service is doing this kind of operation and behave like this. You don't need to go inside the code and check who is calling what and so on and so far. So it's a really good way of just splitting each of the modules. The problem with this, then also even you can define teams for modules. Since usually these modules are just connected by the API, probably you can still use the same approach that you're using with microservices. So you have several teams, all of them working the same code base, but in different folders. So probably it's like unlikely that there are going to be some kind of merge conflicts. And yeah, the problem with this is that, of course, nobody I mean that everyone can just go to the implementation folder and say, yeah, and this class is public, right? So for this reason, you need to enforce your code review. So you need to do code reviews and say, hey, look, this is an MPL and it's public, so please don't do this. Also, you can use tools like PMD, Code Assert, Check Style, or maybe an Enforcer to just have some automatic ways of detecting these violations. Or even, and this is quite hacky, is that if someone is smart enough to say, and I know that this class is private, but I'm going to use reflection. Nobody can avoid you to do that. For this reason, in the code review, you need to also pay attention on the reflection calls, right? But if you do this, you see that you get it exactly the same that in microservices. So different code bases, separated, isolated, and with just one common point to access. The other thing that happens with microservices is the isolation of data, right? So each of the microservices has its own data, its database, so you cannot do some kind of join between service A and service B, right? You need to do a call to service B. Again, we can do this with monolith. It's not a problem. There are several approaches, but this is the one that works better. And basically is that you have all the services, and each of the services is mapped in a schema. So one service or one module, it's one schema. You have the game schema, the review schema, and the tail schema. This is important. The second thing is that the joins might only be happen inside the module. So you have a game with several tables inside this schema, then you need to do the joins between these schema, but not joins with tables of another schema. And this is important. This means that the code review, you need to pay attention on the code review and also take care of JPA and lazy collections, because maybe in the JPA model you just put there a class which is from another module, and then when you do the get, you're doing a join. So take care about this. But of course, I mean that we don't need to get crazy about trying to replicate what is in microservices in the monolith. We have referential integrity across the schemas, so just use it. Something that you don't have with microservices. This is the integrity of data across all the services. With this, with monolith, you can do it. So just add foreign keys when it's necessary, even if there are between schemas. Yeah?
So you don't want us to make joins over multiple schemas?
Yeah, exactly. Like it happens with microservices.
Because it's so efficient.
Yeah, but it's like microservices, right? In microservices, this is one thing that you need to happen, and it's not efficient at all, let's say. And this way, yes, it's true that you are paying some kind of performance in this way, but you will see now that you can fix it in some ways. But yeah, it's true that it's like you get it, this kind of thing. But I think that, well, yeah, this is just a performing thing that you need to see if you want to pay off of this or not. And you will see why it's important to do it in that way in the final of the presentation. But at the end, it's like what you want, right? And you choose, and yeah, but yeah, that's true. And finally, remember that with microservices, you have an eventual consistency. So you don't see the real wall. You see something that might be now, but maybe not. And with now, you can have global transactions. So it doesn't matter if you are using different schemas, just use a global transaction to get it. All the time, you can see the real wall in your system. Yeah, there are tools like Flywheel and Liquibase for populating all these schemas and tables and so on so far. And in case of you said, I don't know this, how must be done, then think that if you are implementing a microservice architecture and then said, how I will do this, and then just implement it in that way, although it's a monolith. This is the safest way. This is about the isolation. We see how to isolate your code, how to isolate your database. Another thing that it's used in microservices is the reactive approach, right? Basically, what's happened with microservices is that each service uses network to communicate to another services. And of course, they are slower than a local call. So what happens is that what we want to do is execute all these things in parallel. And I think that one of the best tool in Java is Rx Java, which is a library for composing asynchronous programs. And it looks like something like this. Notice that now here I have this operation with this a combiner, which is a tip. Tip, it means that I want to execute some operations and then join the result of all of them. Then I have these three calls, get game, get details, and get reviews, which is the three operations from three different modules. Each of them will do DB call. Then you need to set where to run them. And you said that you can think about this scheduler as a thread pool. If you set here, for example, that this pool is just one thread, then all the methods will be executed sequentially. But if you do a thread pool of 10 threads, then it will execute all of them in parallel. Finally, it's like, okay, and now when I have all the data, get it from each of the services, how I join, and I create a game info with all the game, the details, and the reviews. And finally, what I do is just, okay, and when I have everything joined, what I want to do, and it's just send the game info. Notice that in this case, get game is just a local call, get details is a local call, and get reviews is a local call. There is no network call. I know that this in microservices architecture will be a network call, but in this case, it's just a local call. So it's pretty much faster, but at the same time, you can parallelize. Doesn't matter, it's faster that you cannot parallelize. So this is something that you can import in your monolith from the microservices architecture. Another thing that happens with microservices is network. There are a lot of network calls, right? Because you have one service, you need to communicate with other services to get it and post data. And usually what's happened is that the network fails. And when it fails, you need to see how you recover from this network fail. You need to make your services resilient. So if there is a network failure and the program fails, it does not just blow all the service. And you will say, yeah, but in monolith there is no network calls, right? Everything is local, and that's true in the sense of services, but not in the sense of databases, JMS queues, mail servers. All these services are also running in the network call. So we can use what we have learned from microservices. And this is basically the well-known circuit breaker pattern. Everyone knows the circuit breaker pattern? Yeah? No? Well, basically the circuit breaker pattern is a way to grab a function inside a circuit breaker. And then if there is some threshold error is reached, the circuit is stripped. So any further call, instead of being called, it just automatically returns the error. In this way, since the expensive operations like creating a socket, creating a thread, and so on and so forth, that it's really expensive for the operative system, are not done. Because you already know that it's going to fail because it failed previously. So instead of this, it just returns the error. And after some time, when you get it a new request, then it will try it again and said, okay, I know that it has passed like 5 seconds failing. Let me try now if it works or not. And then if it works, then the circuit is closed, and then all the communications continues as usually. But if not, then the circuit is open, and it's automatically returned error without executing the real code. And there are several implementations. I think that there is resilience for J and Strix. Probably most of you are using Strix if you are using circuit breaker, but I prefer resilient for J. And the reason is that it just has one dependency, which is babar for functional programming. That's all. If you check Strix, you will see that you are populating your class path with a lot of dependencies. And then maybe you get run on this dependency hell problem with Java. And to just use resilient for J, you define the circuit breaker with a name. Here you grab the function. In this case, I'm doing entity manager.find, so this is the communication to the database using JPA. And finally, what I say is like, and when there is an error, then just return me an empty result. So if there is an error, it will return an empty result, and all the next communication through this database, it will return always an empty until some time has elapsed. Let me show you a demo so you see all these things with code. And okay. This is the application. This is what we've seen, that we have details, game page, and reviews. And basically we can change, for example, game page, it have the API and MPL and details as well. The API of details, it just contains the interface, which is public, which have a method that's called find detail by game ID, which you pass along, and then it returns an optional to say because maybe there is no detail. And then there is the detail model. And if you check the MPL, it's pretty much the same, but it's just a class which is package scope, and it contains the implementation of the detail service and all the, that in this case the circuit breaker and all the implementation. And if you check how to consume this service, you can go here. And I'm just injecting the detail service, and then using CDI, it will automatically resolve the detail service MPL to this detail service. So notice that now here I don't have any import about the MPL modules. Now I need your help this is okay, this is the games that I have in the database. I have the first one is The Secret of Monkey Island. Everyone played The Secret of Monkey Island? Yeah, okay. With I put it here, if I remember correctly, 4 stars. It's 1 to 0 to 5. 4 stars is okay. Maybe 5, 3. What? 5? Okay, 5. Next one, Monkey Island 2. I put it a 5. I like it more. Monkey Island 2 that 1, but what I put 5, 4, 5 as well. Okay. Next one, Indiana Jones and the Fate of Atlantis. This is less famous, but I put it a 4. I enjoyed this, that you can play several characters at the same time and several paths. 5 as well, sure. Let's put it a 5. Next one, Doom. Yeah, the first or one of the first, first person shooter. I put it a 3. I mean that I prefer Doom 2, but 3 is okay. 4, 1, 3, 5 as well. Okay, 5 as well. Next one, Day of the Tentacle. I put it a 5. I enjoyed so much this. 5 as well. Okay. And then the other one is the Thimbleweed Park, which is one from Ron Gilbert that was released like 1 year ago or so. I put it a 0 because I have not played. Anyone played this game? 5 now. If you have not played, you're gonna say a 5, right? So we left it at 0, right? So I mean to have something different. Yes, if not. Okay, now I'm going to just to show you that it worked. I'm going to package. Okay, and I mean that this deploys the application so you can see that it works. So the number 5, let's see. Okay, number 5 was Day of the Tentacle. You said 5. You have here the 5. The number 1, it's The Secret of Monkey Island. We also said 5, so you have here the 5 star and all the information. And notice that here what I'm doing is just querying the game details, the game and the rate and the reviews with the ratings and put it everything together, running. I mean everything locally. And just to see that the 5, it's 5. Sorry, the 6. It's a 0 as we said, right? So it works. Maybe you are asking now, okay, how I can ensure that there is no communication between API and EMPL, and basically you just need to do one thing, which is like using code assert, which is this tool, and the important is like this one, dependency, right? This test, it's a JUnit test. I know that now you said, what is this inner class here? It sounds really strange. Yeah, it's really easy. Notice that the class is called RG, Lord of the Jars Games, right? If you check my package, you see that there is an RG, Lord of the Jars Games. So it's a way to check this class is about having rules for this package. And then we have then we have fields, these fields, which is called game API, game MPL, details API, and reviews API, which basically says that org.lordofthejars.games.game, right? This is the package. org.lordofthejars.games.game.api. So it also split the camel case from the fields as well. So you can set all the packages, right? This is a way of checking or setting the packages. And then you set just these defined rules which say game, so org.lordofthejars.games.game must use game.api, details.api, and reviews.api. And game API may use game and game API. So I'm defining the rules. And if any other communication, it's a failure. It's a test failure. And then I'm saying I want to check these dependencies, but just think about that there are dependencies like java.star, javax, FreeMarker, and eo.reactivex, which comes from RxJava. It are external dependencies. Don't take it into dependency analysis. So now if I run it here, the test, when I deploy it, here, this test has run and checked that everything is perfect. If I would use some, for example, details.mpl in the code, so here I have an import. Here, for example, I had an import of details.mpl, then this test will fail. We said, you are using a forbidden package. So this is the way how you can automatically set this isolation between modules. So let's continue in the journey. Front ends. Well, I'm not a super expert of front ends, but yeah, I'm in the microservices group in Red Hat, and all of them are talking about web components and custom elements, because it allows you to split the work between front ends. So each of the microservices can contain the front end as well inside the repo. So the final page is like a composition of custom elements. As I said, I'm not super expert, but this is JavaScript code. Basically, you define a class that extends from HTML element. Then you have a connected callback method where you put the HTML code that should be injected inside the HTML page. And of course, here you can use Angular, Vue, or any JavaScript framework. Then you need to register. So you say that checkout basket, which is the tag, it's going to be checkout basket class. And then you just need to do this. Put it in your HTML code, checkout basket, and then at runtime, this checkout basket tag is going to be replaced by the inner HTML defined in the connection callback. As I said, I'm not a super expert about this, but you can read a lot in the developers Google site and also in the microfrontends.org. I really recommend it that if you are in the microservices bandwagon and you have problems with the front end, you check these links to learn how to split the work between the front end team. Another thing that you should do is embrace DevOps, right? One of the important things about microservices is that they reduce the time between committing a change to the system and the change being placed into normal production environment, and while you're ensuring the high quality, right? This is what DevOps does. So DevOps tries to avoid that you takes like months to release something, but just release several times every day. And in my opinion, one of the best technologies that help on developing and releasing faster is Docker. And it was really popular because of microservices. And I mean that it's awesome because it allows you to define your stack. So you set your Docker file, a set of prerequisites to run your application, like the JDBC drivers, the application server that you want to use, the Java version, which is really important. I remember working in a company that the software works on pre-production but not on production, and it was because the minor version of JVM, because of the crypto libraries. So these minor changes are also important, and it's really important to have the same versions in pre-production, production, and so on and so forth. So Docker helps you a lot. And the good thing is that this standardized the way how we can deploy, because in the past what I had, it was like, hey man, I've created this WAR file that it's placed here. I send an email to the ops guys and said, look, take this WAR file, copy to the Wi-Fi deployment folder, and then you have to boot up a PostgreSQL, copy these files, configuration files here and there, and so on and so far, and be aware that everything is done perfectly, right? This is how we work some time ago. And then I moved to another company, and I said, I need to send an email for deploying, and they said, oh no, we are really smart. We are using a wiki page. And I was like, okay, it's exactly the same, right? Because the wiki page becomes updated, then you always have problems on Friday night trying to deploy something, so wiki page is exactly the same problem. And I think that Docker simplified a lot, because you just create your Docker file and you go to the ops guy and say, just run Docker build and put it this, and this is what it works. So basically, this is my a schema of the applications that I've developed using the monolith approach, which basically is a load balancer with two hardware servers with running my application, and then I had 3 databases, one database for each service and one for backup. And yeah, I mean that in case of failed one node, then there were an operation guide that said, oh, this node has failed, I'm going to boot up again, or just trying to find what's happening and reboot the system, and so on and so far. So it was like a manual thing. Of course, yeah, this is not the right way to do it, but I'm sure that everyone here has suffered this. And I said that Docker is a really good way to adopt in the monolith. So how you do this, right? You start doing docker run service 1, docker run service 1 mirror it, docker run Postgre, docker run, blah, 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 right? So you can just start doing docker run, docker run, docker run. Notice that in this way, you didn't scale with the traffic. You have 2 services and that's all. And if one is down, then you need someone there to say docker run and run it again, the container that has crashed. So the thing is that why you don't start deploying in a cluster, in a Kubernetes cluster or OpenShift cluster. At the end, I mean, the OpenShift is the Kubernetes version of Red Hat, which is open source. So nothing blocks you to create a cluster. Maybe it's a small cluster with just 4 machines or 6 machines, but it's okay, because the good thing about Kubernetes is that everything is managed automatically. You just deploy your service there. In case of failures, automatically the cluster will boot up a new service for you, or it will find a machine that fits your requirements and will put there the service. Or if you get it high level traffic, then you could say, Kubernetes can say, oh, look, you are increasing your traffic, so I'm going to find another machine on my cluster and create a mirror of your service there. And everything is automatically. So why we need to do things manually when we can do it automatically? And notice that it's really easy. You just say, this is my service. I want 2 replicas of the service. And the image that I want to run is this one, game.1.0.0. And I really enjoyed doing this, because now that I'm using, we are developing microservices, there are really huge Kubernetes files, right, to deploy the microservices and so on and so far. In this case, it was really simple. And finally, the port. And this looks like this, right? You have this OpenShift, which is a Kubernetes, as I said, and you have the game service with 2 pods. So you have these 2 services, and then the CockroachDB with 3 pods. This is a database, a SQL database that it works really, really well for distributed systems. So I recommend you that instead of going to MySQL or PostgreSQL, give an opportunity to CockroachDB for these distributed systems. And here, this is the reverse proxy router. So this load balancer is done automatically by OpenShift. And the number of instances. Another thing is like microservices must be cloud native applications. Basically, because by definition, a microservice must be able to scale up and down at a rapid rate, and automatically, and recover automatically from errors. How I work with my monolith again, I have this kind of infrastructure where I have the load balancer and so on and so forth, and then I have a request, and then this load balancer creates a sticky session, which basically is a pair between my computer and the server that's going to serve my request. Then suppose that I want to buy something, so I add a product into the cart, and for any reason load balancer decides that I have to go to this node, so I put the shopping cart in the user ID here. This is the session, right? This is the HTTP session is stored in the server, and then with the sticky session, all my all my next communication will be redirected to this server as well. But what's happening if this service goes down? I lost the shopping cart, right? So it's like that you need to relog again, and so on and so forth. This is how it worked, or how I work in the past. I'm not saying that everyone here is using this, but probably most of you has suffered the sticky session problems. And basically what how microservices fix this is using an in-memory data grid, which basically is a data structure that resides internally in the RAM and is distributed among multiple servers. So what's happened that if, for example, I have here a request, it doesn't matter if it goes to node A or node B, but then the shopping cart is shared across all the nodes automatically. And they are in RAM, so it's really fast to get access from the data. If this goes down, it doesn't matter. The load balancer will say, okay, meanwhile, the new node is not up and running, I will redirect all the traffic to the other node. And it doesn't matter if your session was in the service A or service B, because this in-memory data grid maintains the state across all the cluster. And I think that one of the best in-memory data grids is InfiniSpan, which integrates very well with Kubernetes. Well, another thing that is really important is, like, with microservices, we are starting releasing as unicorns. That means that we are releasing like 4 times per day instead of 1 time every 6 months. So how they release the unicorns? Basically, things of the containers is really easy. Just build a Docker file with all your stuff. You build a container, right? So you do this Docker build and you put it in the Docker registry. Then you deploy this to the cluster, to the Kubernetes cluster. So you have, in this case, in case of Kubernetes, you have a pod. They're on production, but you are not receiving traffic. So it's deployed, but not released. And then it's when it happens that, okay, and now what? And one of the things that are coming with microservices is the testing in productions. So you put something inside the cluster, a new version, and then you check what's happened with real traffic. And this is really important to do it in that way, because production is always different, right? There is different DNS, different hardware, different network layers, or network topology, sorry. And also, the real traffic is always different from the test traffic. Maybe you get it, people with strange browsers and so on and so forth. So it's really interesting to have this testing and production strategy. And there are basically 3 ways of testing in production. The first one is that blue-green deployment. Basically, you have the blue deployment, which is one that it's running. And then you deploy this new Docker container, and then you switch from blue to green. Then all the traffic goes to green. Then you start monitoring the responses. And if you see that there is a high error rate, then you switch back to the blue. So in this way, at least you have the both environment, and you can switch back and forward to check if it works or not. Notice that this has a really big problem, is that if there is an error, all your traffic will receive the error. So to avoid this, we have canary releases that instead of switching all traffic to the new version, you start just switching for example, 1% of the traffic. So that 1% of your users will start reaching the new service. If it goes okay, then you increase to 5. Goes okay, 10, 20, 50, 90%, 10%, and then you can switch off the other service. If there is a failure, just 1% of the users will receive this failure. So it's better than blue-green. And the third one is like dark launchers or shadowing traffic, which basically is like, I have a user that has a request, and then what I do is just send this request to the old service and the new service. The request to the old service is going to be the answer that is going to be sent. But the new one is going to be like a fire and forget. So I'm going to send the request to the new service, and the user will never notice that his request has also reached the new service. And then on the other side, I have a monitoring system which checks if everything is behaving as expected. When I see that, yes, it seems that all the requests that are just with shadowed or shadow mirror, it's mirrored, it's working, then I will say, okay, it's working, let's try to start the canary release process, sending the 1% of the real traffic there, and so on and so far. So there are these 3 techniques, and in each case, you must decide which is the best one that fits in your use case. And finally, when you have test and you have all the users to the new service, you have released your new service. And this is something really typical for microservices, but I recommend you that you also do this for your monolith, because it's really easier than in microservices, and you will get it, in touch of what means testing in production. Yeah, some tools for testing for automate all this process is like source to image tool, OpenShift or Fabricate. It automates all these steps. And then if you want to get into testing in production, I recommend you Tate and Debezium for dealing with the big problem of state or the persistence problem, right? Because you are testing in production, but you are inserting data inside your databases as well. And maybe there is failure, so you are adding some noise on your DB. So these tools can help you with this. So let's wind down. Advantages of monolith. Nowadays it seems that monolith is a shit, and if you are writing monolith, you are not so cool. But you see that you can use so cool technologies for monolith, and you get some advantages like local calls. There is no network, just memory call. All parts are always up. You don't need to figure out what's happening if the other service is down and so on and so forth. And here it is like everything is up or everything is down because everything is running the same JVM. It's easy to debug. If you think about how you will debug a microservice architecture, is really hard because everything is asynchronous. It's always a network, so you need to start configuring the debug in remote mode and so on and so forth. So it's hard. It's easy to debug a monolith, I guess. It's also easy to test, right? Everything runs on your machine. You don't need to boot up and start doing some kind of service virtualization. It's really easy to refactor. I recommend you the experience of refactor a microservice architecture, because you change one service and then you need to say, okay, I've changed the parameter, so now I changed the parameter from name to full name, and I need to get it who calls my service and notify them that now it's not name but it's full name, right? And because and they need to change, if you're sending JSON, how they parse the JSON. In this sense, of course, you can use contract testing, but then you need to write contract tests for that. You see the real world every time, because you have transactions, global transactions, so there is no eventual consistency. It's easy to deploy. That in theory, microservices should be deployed in isolated way, so you can deploy any service independently. But this happens when you have a product like after 2 years. But at the beginning, this usually it's not that case. So you need to coordinate deploying a bunch of new services. So in this one, it's just one service. You deploy the WAR, and you're fine. And remember that nobody's avoids you to use polyglot languages. Of course, it's JVM languages, but you can create a module with Kotlin, another module with Groovy, another one with Scala, another one with Java. You can do that because at the end, everything is compiled and run in the JVM. And also, you can use polyglot DBs. I show here SQL, but you can use SQL plus MongoDB or SQL plus Neo4j or whatever. So you can use NoSQL databases or polyglot databases in your monolith as well. Finally, one thing that my college board says or shows is or coined the name of digital Darwinism. And let me tell you something that is not related with technology. It's like, okay, we are in the bipedalism way. So when we start, walking with 2 legs, we had 2 hands free, so we can manipulate things, right? But it has been discovered that we can manipulate things not because we are bipedalism, but because the brain, before we walk in 2 legs, start changing something in the brain. So when we became bipedalism, we can move the hands and take things and carry things. So there was a preparation before bipedalism, so we could manage things. And this is exactly the same. You cannot go say, yeah, I'm going to do microservices, and that's all. No, that's not happening that way. There is a path for this. The first one that you need to do is reorganization to DevOps. So you need to be able to develop and deploy and release quickly, several times per day or several times per week, but not every 6 months. Because if you release every 6 months, with microservices, you're continue releasing every 6 months. So you need to rearrange to DevOps. Then you need also to move to a self-service on-demand elastic infrastructure, which basically means, like, I remember in one company that they said, hey, I need a PostgreSQL server for running some tests, and said, yeah, you will have it in 1 week. So this is not how it works. I mean that I want a PostgreSQL machine to run my test, so I'm going to a page and say, I want a Postgre, and with 5 seconds, I have my server running there. This is the next step. You need to automate everything, just in Puppet, Chef, Ansible, or Kubernetes, whatever, but you need to have your deployment process automated. Move to CI/CD deployment pipelines. You need to define a current pipeline which automates everything, and then you have your application, and you said, this is the application that I want to deploy. I'm going to run the test, run the acceptance test. Someone decides that goes to production. I push the OK button, I go to production. The next thing is these advanced deployment techniques that I show you. After that, when you have everything automated and it's deployed to your cluster, then you said, I'm going to try blue-green deployments, canary releases, or dark launches. And you get some knowledge about that. And finally, you're going to start microservices. When you have all these things, you're going to start deploying microservices, doing microservices, and it will be a success. If you don't do it in that way, it's you in the near future, right? All the containers that are blowing, you don't know exactly what is happening, and trying to, doing a firefighter thing. Last thing, important thing. You know Stack Overflow? Yeah, I think that if Stack Overflow is down, now it's time for a coffee, right? And this is the page, and maybe you said, oh yeah, it's really cool. You have like a stats service, you have the user service, you have the hour service, the question service with this thing, and then you have the advertise service for that, right? It seems that for the amount of traffic that Stack Overflow is receiving and this layout, it seems that it's like perfect for a microservice architecture, right? The truth is that no, it's a monolith. All Stack Overflow is monolith application with 10 servers, load balancers, and so on and so far, but it's a monolith. There is no microservice architecture, and they are serving all our requests, all our answers, all our questions, everything with a monolith. So it's not necessary to move to microservices because we want. It's just because we need. And one important thing is that please one day go to the bottom of the page of Stack Overflow, and you will see this number. And you see that maybe every hour it changes like 3 or 4 times. So they are deploying 10, 15, 20 times every day. I don't know how many times, but it's a monolith. So you can deploy several times using monolith. Finally, I take this quote from Spock that is like, long life and prosper to monolith, because as you said, it works. And that's all. If you have any question, you can send me an email or just tweet me. Thank you very much. Well, if we have 2 minutes, if there is any question. Okay, great. Thank you.